Okay, so can folks remote see the screen?
Yeah, we can.
Okay, great. So let's get started. So there's a few things I want to kind of clarify. There is a question over Piazza regarding what it really means by group activity or activities. So on Canvas, you can submit up to 5 activities. So those are under Canvas assignment. They're not really graded, they're just participation point. So throughout the semester, you're going to get 15 to 20 lectures, and each one of them come with activity. If we have time during the lecture, you would be doing those activities together as a group, either online in the breakout room or in person, forming small groups in the classroom. But sometimes we run out of time during the lecture. You can do those sort of after the class, again, with your classmates or by yourself. And when you actually submit it, there's no particular ordering you need to submit. As long as you submit 5 out of those 15, 20 activities, you should be fine. Does that make sense? Yeah, so because we're doing a little bit crash course over Python, so depends on how many questions I get during the lecture. Sometimes we may or may not have time for activities right during the class, but feel free to do those after class. And again, there are office hours online and in person. So if you have questions with those exercises, feel free to kind of come to office hours. Okay. Any other questions? Yeah, go ahead.
I just, for those activities, do we need to turn them in on the day that we have the lecture, or can they be posted after?
You can do it after. It's recommended to not space them too far apart because the exercise, right, is associated with that particular lecture. So if you do it on the day, it's help you to kind of understand where might be some of the gaps in your knowledge. So you can kind of fill those gaps very quickly.
Okay, thank you.
Yep. Okay, so today we're going to go over a little bit more complicated part with a few review over Pandas series. And then we're going to move on to file IO, so input output. And then we're going to move on to the final thing, data frames. You're going to be using quite a bit of a data frame. So this is actually an important lecture for you. And of course, for any data science task, the first thing you're going to do is to load the data, read the data, parse the data, and perform data wrangling. For any real world applications, this is something you may or may not have experienced before, is that you might end up spending more than the expected time you want on actually the data wrangling part. So we're going to go over some of those common techniques for data wrangling using data frames. Of course, there's a lot more to learn on your own by reading some of those Python tutorial, but we want to give you sort of a first taste of how to do data wrangling using data frames. All right. Okay, so a quick recap. Towards the end of the last lecture, we talked about Pandas series. So again, first of all, you're going to import the package. Yes. And then once you import the package, sorry, just a sec. You're going to specify a Pandas series. As I said before, you can actually specify the payload of a Pandas series. So think about a Pandas series. Another way to think about Pandas series, so you think about it as a column of a table. This is sort of a piece of your data. And later on, when you work with data frames, you can see that actually data frames stores a table of data, and each of those columns pretty much corresponding to a series. So in this particular case, again, we can initialize the payload, which is the data actually attached, which is the year, using a list. And then you can specify a name for the series, and also you can specify the index that corresponding to those years. And then, of course, you can then do a little bit search over using the index. So in this case, I want to return the data items associated with the index Pink Floyd. And remember, in this particular case, if you have multiple keys that is a same key, then it's going to return all the entries that has this key. Okay. Now, almost the same thing as list, that you can actually do indexing and slicing. And then there's 2 different things you can use. One is iLock and one is lock. So iLock is where you actually can slice based on the actual position. In this case, again, thinking about this as a column of your data. If you do one the ilog with 1 and 3, if you look at the indices, it's saying that, thinking about index starting from 0, then it's starting 1, 2, and 3. So it's from Beatles to Pink Floyd. Oh, sorry, it's not including 3, sorry. It's actually up to 1, 2, yeah, up to less than 3, all right? Now with log, what you can do is you actually provide the corresponding index or the key. And in this particular case, you want to say, okay, I want everything between Zeppelin, the key Zeppelin, and then the key Pink Floyd. So again, if you look at the data, anything between Zeppelin and Pink Floyd are sort of the third, fourth, and fifth row, and that's what you return. Again, the difference is that if you use log and you provide the key, it's going to return the particular record associated with that key. So in this case, because it's ended with Pink Floyd, it's going to include the data associated with Pink Floyd and the key Pink Floyd. So the other thing you could do is a little bit unconventional. Let's first do ilog. Again, if you do ilog, if you go from 0 to 3, it's going to actually look at, again, the record from 0. And in this particular case, you can index it into this, treating this almost as an array. And in this particular case, it's returning the second record and then the third record, okay? Versus in here, well, remember, it's only returning 2 record because it's starting from index 1, goes to 2, but not including 3, okay? That's right there. Now, in here, did I run this one? This is again using the log with the key. All right, so the one thing that is interesting is, again, first I'm going to display my record of my data. You can actually pass a Boolean list. What this do is true, it means I'm going to take this record, false means I'm not going to take the record. So this is really a first taste of masking. So this is really about selecting a subset of my data using the Boolean variable. So in this particular case, again, if you look at this record, right, it has 5 pieces of data and it says true, meaning that the first row I'm going to take. False, I'm not going to take the second row, not the third row, but I'm going to take the fourth row and not the fifth row. So what is returning is the ones that corresponding to the true Boolean variable. Okay, so this is a first taste of a masking. So if you think about it, what is a true and false do? It's basically corresponding to do I select or not select. But now when you actually want to do some parsing of your data, what you want to do is provide a condition that returns this true or false. For example, maybe I only want to return the record that associated with the year after 1960. Then you can put sort of an inequality to create this Boolean variable, this Boolean list. So that is where a mask can come from. And when you create a mask, it helps you filter your data. So in this particular case, I'm creating a mask. This mask is saying that I'm going to look at the bands which are founded after 1964. So if I actually output this mask right now, this mask is saying that, okay, again, if you look at the data, is Stones founded after 1962? No. So the masks here, it says false. The Beatles? No. Zeppelin? Yes, because it's founded in 1968. So once you put out this mask, what you can do is you basically, this is a little bit sort of combined effect, is you are actually using this mask at the same time already filtering it. So in this case, I only, if I look at this mask, it only gives true to the data record that is satisfy my condition. Okay. Now, you can also, this is just, this is called broadcasting. And you can also, in this particular case, I'm using an inequality to do the broadcasting, but I also can do numerical operations. I mean, of course, this is not logically making sense, but what I'm trying to do here is say, I'm going to take all the year and I'm going to time by 12, right? What I'm doing here is that, this is the number of the year it's founded and I just multiply it by 12. So pretty much this is an operation you can impose on your series. So for every single record, you can perform this operation, right? This can be a sort of Boolean operation that return true or false, or it can operation that is, for example, string manipulation or numerical manipulation. In this case, I'm just multiplying it by 12. So now, remember I have specified a mask, which is based on whether it's founded after 1964 or not. Now, if I actually do that, it's now returned a new copy of my data that I only returned the ones that is true. So this is literally using the mask to do filtering. So now this became my filtered data where I'm only keeping a certain desirable records. Okay. Yes, is there a question?
I said that's cool.
Yes. Okay. So I'm hoping up until this point, you still enjoy data wrangling. I'm pretty sure at some point with your real data, there is going to be a cursing phase. But ultimately, there are a lot of very powerful things that Panda gives to you. So, you know, we'll actually go through some exercise today where we'll look at how to actually do data wrangling from scratch versus how you actually do it with data frames, which makes your life much easier. Okay. Now, remember, now I have filtered my data. You can also do shorthand expression. So this previous sort of several lines, line 13 versus define the mask, line 11, they can also be condensed into one single line. And this is another thing some people argue is the beauty of Python is you can have very short condensed expressions. So the same operation you just did is to say, I'm going to put my mask inside my square bracket. And then at the same time, I'm filtering my data using this expression. So that returns you the same thing. So if you parse this expression, what it does, this is my original series, and I put in a mask. It says I want everything that is founded after 1967. Once I do that, it's going to return a new series that only retains the record that satisfies my condition. Okay, yes?
So now the next time you use mask founded, is it going to give you this 1968-2012?
I believe this is making a copy. Let's double check. So I just printed the original thing, right? So you can do this, you can say new bands equal, and you can do new bands, right? So what this does is that the new bands is a new copy, right? But this is a good thing to kind of remember whether this operation is operating on my original record or is actually making a real copy. And then there's some differences over certain operations that you want to prevent unintentional modification to your original data. Yes?
And the modifications never affect the keys, they only affect the values.
No, actually, no, it's not the key, it's entire record. Remember what happened if you look at the original data, this is the entire record that is both the key value pair, right? So it's not affecting the key.
Right, so it only affects the values of it. Because like, for
Yes,
example,
yes, this is a filtering operation that is operating on the value, right? I want to look at, so think about the key as just some sort of identifier. It's like, you know, every student has a student ID. It's just an identifier for that particular record. But when you actually modify, you're actually looking at the value associated with that record, whether that satisfies your condition. Okay. I do remember I have an example later that you can also modify the key. Okay. Now you can explore the series, and then there's some statistics you can do. So for example, this is a series initialized again with a list, and then there's some non-value. And now if I do count, it's going to return 6 versus 7 because it's not going to count the non-value. Okay, but this is basic statistics. So the same thing, you can do sum. Then if you do sum, you just take this whole thing, add them all together. So you're already seeing some of the powerful thing about series is you can do some simple statistics that you don't have to code from scratch. Okay, and you can do mean, you can do medium. You can also look at all the statistics, and that is dot describe. So in this case, count, mean, standard deviation, all the other statistics, 25% quantile, they are all going to be reported to you. So if you want to do a simple analysis of your data, this is a good tool to use. Okay, now let's move on to a little bit over data wrangling. A lot of cases you're going to deal with in real world data is you lose, oh, there's some questions. Oh, okay. It looks like it's answered. Okay, yes. If you really want my attention for people who are remote, feel free to kind of mute yourself and ask me questions because I can't really see the chat all the time. Thank you. All right, so the first step of dealing with data wrangling is deal with missing data or not available data. And then series come with drop NA. And what that do is that if you have NaN, which is basically non-values in your data set or missing data, it's going to drop it like it is. So remember, I have this particular thing where I have a non-value right here, and this operation is going to get rid of it. Okay. And of course, yes.
For the drop NA, does it have to be called out as none, or can it be called out as, can you specify something? So if the data had null or NA, could it drop those automatically, or do you have to specify that?
Can you hold that question? Because I do believe, and remind me if I don't have that example, I might have example down like a few pages down.
Yeah, no worries.
Yeah, to providing a little bit extra into the drop NA.
Yeah.
Again, you can also do non-numerical data, right? So in this particular case, you can, of course, in this case, you are dealing with years, but in some way that the Python doesn't know it's actually really year. So you're going to treat it as a number and it's going to do its operation, okay? And of course, you can also directly query a particular quanti. For example, for the number series, I have the quanti at 2.25 quanti, it's going to return it. Same thing, you can do max and min, all right? Now, the next thing you want to do is sort, okay? That again, if you automatically just call sort without any argument, it's going to sort from smallest to largest. Okay, so now what's interesting about it, notice what happened to the key. The key is kind of permuted together with the key value pair, okay? And of course, the next question is how do you do a descending sort? If you want to do descending sort, you just put this parameter to say ascending is equal to false, okay? So it's descending. Now, the next thing is that, okay, this might not be ideal because when you sort, the whole key value pair is sorted, but I kind of really want to reorder them. I want to update the key or the index. So this is what you call reset the indices. So you can sort and you can say drop equal to true. This just means that this is essentially, let's see, this is again, did I do that? Okay, I already inversely sorted. So if you recall here, I already inversely sorted, but I did drop equal to true. That means I'm going to re-index them. So now after this performance, my index is in some sense reset so that it's corresponding to number of rows in my record, okay? You can also sort the index. So this is where you can execute here, like sort index, okay? And then this gives you our sorting of the corresponding index, okay? So now let's move beyond just simple statistics and sorting. The same way you can operate, if you think about list comprehension, you can kind of manipulate using some expression on the values in a list. You can use something for series. This is called a map. So the map is essentially a function that transforms all the values in the series. So, so I'm going to use some very artificial example here. For example, in this case, I'm going to import sort of the package datetime, which has a bunch of functions that deal with conversions between dates and so on. So I'm going to define a function that takes an integer year to a specific date. And then we're going to say that date is going to be that year and January 1st. So what I do is if somebody give me a year, then I'm going to return the year and January 1st of that year. So I kind of did a little bit conversion to play the year and convert through this new format, okay? Now, remember, I have this sorted number, which are all the years from the records. And then when I do dot map, and providing the name of my function. What this do is you just apply this function to every single value of my data. So if I actually print it out, remember the previous one, the new sorting number is just the year, 1960, 62, 65. But by applying this function, it's basically transform my data into this new format, okay? All right, so like I said, this is very, very similar to list comprehension, which is basically providing an operation over every element in your series. You can also use the map function to pass into a dictionary that then modify the matching object. Okay, so this is where it became powerful, but also you have to use this with caution. So, oops, I didn't want to go there. Where did I jump to? Oh yeah, right here. Okay, so what do I have? If you look at the original record, remember, forget about the transformation part because that's create a new thing, but remember here's 1960, 1962, 1965, 1968, and so on. What this is telling the operation is I'm going to find the value that says 1965. I'm going to replace it with 1945. I'm going to find the value that says 2012. I'm going to replace it with 1999. I'm going to find the sort of value that says 1968 and replace it with a string that says what. And then what you see here is that it's going to record that record and perform this replacement. All right. Yes.
Where are the NAS coming from?
Yeah, because this transformation does not apply to it. So, this is again something you have to be a little bit careful. Is that if by default you would assume, oh, this operation wouldn't touch my record, but if this record doesn't sort of match my condition, it just say, oh, I can't do anything with it. I'm just going to say only n. So this is what a little bit careful how you use it, because in some sense it's a mask, but it also kind of every single record is checked against it, right? So you see that the ones that satisfy this condition is modified, the rest is like n. Okay, so now let's talk about data reading. There are a lot of different files that is used for storing data. For example, I show two examples here. One is a JSON file and one is XML file. And we're not going to use it in today's class, but this is going to come back later, especially when you're doing data visualization. Some of those data are better read with JSON files. So think about those files are specific ways to tell you sort of what is the formatting of the data you're expecting. Of course, JSON and XML are more scripted based. It's kind of describe, what's a field, what's a value, and so on. We are going to come back to those data files later. But keep in mind, those are two other data files, data files that data format we're going to deal with. The most simple ones we're going to deal with is called CSV, common separated value file. Surprisingly, even though whenever I tell you, oh, my file is CSV, there's a lot of variations of CSV. It's in some ways, yes, it's people mostly interpret it as a file format, but there's so many variations. So it's better to think about CSV just as a table represented as a text file, right? And then the variation among CSV is very much about what is the delimiter, which is what is the thing that separate different numbers, different values from each other. Okay, so what you see here is that, okay, this is sort of a bunch of artists, album, and so on. And then this is actually the first time when you actually think about parsing this. Of course, if you don't use Python, your natural go-to tool would be Excel, right? You try to say, oh, fire up Excel, I'm going to try to load it. But even when you load Excel, you need to kind of provide some information to Excel to say, how are my data record separated from each other? This is the same thing in the Python language. You need to specify that. Another thing that is interesting here is really this genre is actually should be three things. It basically says Michael Jackson bad, the outbound bad, is actually belongs to 3 different genera. So these 3 words should actually fall onto the same column in a way if you're parsing this into a table. So one way to do this is to specify in quotation marks that all those 3 belongs to one single data item, okay? Okay, so there's more things you can do. Is that, okay, so for today's lecture, there is a preloaded data file that is coming from Wikipedia, which is a list of best-selling album. And then it's already in your current file, which is called hit album CSV. If you actually look at this particular this CSV file, if you just open it up directly, it's going to say artist, album, release, genre, certified sales. Again, double quotation mark means that this is one single name for that particular column. And so on. And then again, if you look at the first record, is that, you know, this double quotation mark is indicating is one single thing that should be read into one single cell if you were going to parse it. Okay. Now, without using data frame, let's go with the hard way first. If you were going to do this yourself, what would you be doing? Let me make sure I'm not. Okay. So first of all, you're going to open the file using the Python keyword open, and you provide the file name, and you're going to say, I'm going to open it. I'm going to read. I'm going to do a read operation. Now, if I actually just print out the content, this is how it looks like. It's a little bit ugly, but this is exactly what read does. It takes a file, it reads each line of a file, and if you look at here, this is really, this particular thing here is a new line character, okay? So it's just going to read it as it is, and very soon we're going to try to see how can we read it line by line, because this is just read it as a whole. Now, of course, you can make it into slightly better, you know, if I do a print content, it's going to perform slightly better, because remember, each time the print sees this /n symbol, it's going to translate to say, I see a new line. So when you print it, it's going to kind of start a new line for every single row of your file, okay? You can, of course, do better, okay? Oh, by the way, very important part is whenever you read and once you're done with this, make sure you close it, okay? Because if you just leave the file open, sometimes it will take over your memory and you're going to have sort of memory leak problem. So once you're done with it, remember to close it. Alternatively, like I said, you can do better, which is you're doing it, you're going to read it line by line. So in this particular case, when I open this file for read, I'm going to read a single line. And when I call it read line, it's going to say, oh, well, it's line 1. So I'm just going to print out the line 1. And now if you have this line, you can run the string operation, which is called split. And what is this split do? It's going to just split this into each individual field. So in this particular case, it's actually split this entire line into a list where every single word in here, other than the ones that is, you know, in double quotation marks, it's going to treat it as a member in my list. Okay, so this will be actually your first very simple way of trying to parse your data. I try to read your file and try to access the first row and all the different words on the first row. Well, of course, just reading the first line isn't sufficient. If you just want to deal with this data line by line, you're going to go do it in a for loop. You're going to keep reading a line, do something with the line, call it again, is going to read the next line. So this is exactly what I do. I'm going to say, well, I'm going to read a line for this, for what I have. And for each line, I'm going to you know, split it into multiple words. And then I'm going to close it and I'm going to look at what my data is. So what this does, this is trying to do is it's going to spit out all the words in my data file. Okay. And of course, append means that each time I get a list of words in that line, I'm going to append it to my data. So now what you see here is actually this list is my first row of my data. It's become a list. My second row of my data become another list. And then I have a list of lists, right? So the length of this list is number of rows. And then for each row, the length of that list is number of words. Okay. So of course, don't forget to close the file after you read it. Now, once I did this, right, I have read the important information that's coming from my CSV file into this list of lists. So remember, when you have a list, you can do slicing, you can indexing into it. So now if I actually, so remember, everything is stored in my list of lists, which is called data. Now what I can do is I can access my data with the individual cell. If I say data 0, it's returning the first entire list, which is the first record. But if I do data 0, 1, what is it going to return? The second element of the first list, which is Thriller, the album. Okay. Now, same thing, you can read, you can write. So remember I said open, earlier on I said open a file, read. I can also open a file to write, right? So this is file input, output, file IO. So now I can open with the W flag, which means I'm going to create a new file that I'm going to write to it. So what this line is, with open as a new file, I'm going to write hello world are still spinning. So if you, of course, if you do this, you can actually open this file exactly what you wrote. Okay. Wait. Okay.
Does writing a new file, it just writes it into your working directory?
Yes.
Okay.
Yeah, so you can provide the directory here to other places, right? But by default is a current working directory, so you don't have to provide the path. Otherwise, you need to provide the path. All right. So, okay, so we can do open a file, read and write. It turns out there's a lot of capabilities Python already provides for you, so you don't have to do this naive slicing. Yes. Right. R means read, W means write. Okay. Actually, I just exceed. I think we're going to take a 5 minutes break. So it's 4:13 right now. We'll return at 4:18. Okay. Is it too fast, or this is a reasonable speed? Okay. What's that? Okay. Just feel free to raise your hand and says, wait a minute, slow down, okay? Yeah, to be fair, like I said, this is a crash course. It's, but, I definitely want you to understand those kind of high level operators.
So this is gonna be like, you're just trying to get us through the basics and then we're gonna actually do different stuff.
Yes. Most likely, as you go through this course, like next week, Anna is going to teach a bunch of statistics associated with using Python libraries. So most likely, what I'm teaching here is the basics that help you understand the Python code and write some basic Python code. But most likely, later on, you are going to constantly refer back to the Python manual. It's to say, oh, I might have not seen this before. What does this mean? Or actually for your final project, which is the second part of the semester, you'll most likely have to learn a bit more of Python to kind of code up your own data project. Yeah, so those are like the crash course to kind of get you started. Yeah.
I had a question.
Yeah.
Are there sample projects on the data science website, or are there any available?
Yeah,
Just to get an idea.
So there are the Hall of Fame, but I don't know if the code, I believe the code might be provided. Let me see. If you go to the webpage, datascience.net, you go to Hall of Fame. I think there are examples of project. They are mostly, actually some of them do have Jupyter Notebook and some of them just have videos. Can you see my screen?
Yeah, I can see it. Yeah.
Yeah, so those are some examples of the best project over the years. So for example, those are, so it will give you, the videos will give you an idea of what has been done before, but looks like this one actually have Jupyter Notebook too. So not all of them has the source code, some of them do, but if you watch the video, it will give you a sense of past project.
Yeah, thank you. That's really helpful just to get an idea.
Yep, yep.
And there's three types. There's one is kernel that's within the department, and if you have like, they would prefer if you have within the department that's outside. That's what that is. We have a permission for those stuff. I know you can see that like if you want, like if you're in the field of it, it's your job. I don't think a lot of people do.
All right, let's resume. So let me go back to the question because there's a question over drop NA. What are the field? So this is sort of the Panda data frame. Well, actually, we haven't reached the data frame, but we'll get to it very soon. But if you actually look at the syntax, it has all the things that, you know, if you don't specify, it's taking the default. I'll explain access very soon. But if you don't provide anything, it's a default. Otherwise, what you can do is you can actually provide additional sort of fields. For example, subsets, meaning that which sort of columns I'm going to modify, and do I operate it in frame? But the one that instead of doing drop NA, what you want to do potentially is fill NA, which we're also going to see very soon. This is to say for any of those NaN values, I'm going to replace it by something else. Because normally, as we will see very soon, when you're actually doing data wrangling, one idea is to say, well, if there's a record that has NaN value, I'm going to ignore it. But sometimes when you have data files, there's a lot of missing value. You don't want to really ignore any records that has NaN. Instead, you want to fill it with a different value so that you can still proceed with your analysis. Okay, so let's get back to where we are. Okay, so data frame. We are, did we go in? Yes, so, okay, so where I'm getting here is, remember we can do, oh wait, let me go further. I think we are still, okay, right here. So you can read and write, but then Python provide a specific CSV library. So you just say import CSV. So it contains some operation with CSV file. So again, you can initialize a data array which stores the value. Now, once you import CSV library, you can just again open a file as a CSV file, and then you can do CSV reader. So what does this do? Remember this more naive operation I did, which is I read it by line and split it into like, list of lists. I can do it in one single line, which is reader. I provide the file, and I'm going to specify what are the symbols that separate my record, and what are by default is double quotation mark that specify it's a single data item, right? Remember I said everything that I want to read as one whole entity is with double quotation mark. This is to specify that. Once you do that, you now have kind of read your file by specifying those configurations. This is also very similar to when you actually first load a CSV file to Excel. You need to tell Excel how to look for separators, how to look for like single entities. This is the same thing. And then the rest of it is a for loop, is to say for everything I have read, I'm going to print each of the row I have read, and then I'm going to put it into a list of lists. Okay, so all the parsing, all the splitting that I have done, I can do it using this one single line. So let's look at what it does. Yeah.
So you're not that one code of that one line of code with CSV reader. Are you splitting and reading splits in that line? Or
Yes, it's reading and splitting. But what it does is actually read my file row by row. And then it's going to split it also. So if you actually look at this print statement, right? So that means for every row in this, what I have read, print the content in the row. So in the first row, it's going to be, looks familiar, it's a list. But it's a list because remember in the previously, I have to do both read line and split to create this list. But now using this one single function csv.reader is going to just read that row and split it. Okay. So
in the commas and the quotes, or it's reading the quotes.
No. So yeah, be careful. This is square bracket. This means this is a list, and this list contain all those items. This is just separating the item inside the list.
I was talking about in the code, which is the limiter quote and the quote characters quote.
Oh yeah, this is saying that yes, this is what is a symbol used in my CSV file to separate the record. This is double quotation is to say I want to treat anything that inside a double quotation as a single data item, right? For example, this word, if you don't, in the original CSV file, this word is put into double quotation mark. So it's treated as a single data item, okay? Now, of course, I have printed out all the row, and then the next thing I'm doing is I can print the header. Let me go down to the bottom. The header, so if you think about what is a header, if you have a table, the header is a first row that tells you what are the fields, okay? And then of course you can also print the data values, which is, so in here, right, the header, when I say data value pop 0, this is just to say I'm thinking the header is the top row. And then I'm also going to print the data values, which are the list of lists. Remember, not only in this thing, I'm printing each row that I have obtained in my file, but I'm also creating a list of lists to appending this row, right? So this data value is a list of lists. So I'm just simply printing it. So this is what we have. This data value is what I did earlier with this data, right? This is a list of lists. So this is the same thing. Okay. So of course you can do this, and then once you have this, remember data values is a list of lists. So so one thing that you have to be a little bit careful is that if I do this, it's going to return a value arrow. Why? Well, somehow in our imagination, we have those sort of numerical values and numerical values that I can convert it to integer or float. But what happened is that when you actually do the conversion, for example, in this last field, where I expect there's going to be a numerical value and I convert it to a float number, but if I'm missing value, then this is going to return an error. So in a way that you can do a type conversion but you can't do direct type conversion when there is missing value. And this is a common mistake, right? Because when you have a table that given to you, you assume there's no missing value, so my type conversion is going to work. But if you actually look at the record, there are, for example, this particular record that the last field is actually empty. So you cannot do a floating conversion. So what you can do, and this is just a simple taste of it, is that you kind of expect I need to handle missing value. And what you do is something called try and exception. So except is essentially I want to catch the exception I just see. Remember what I see here is a value error because I try to convert an empty string to float, and it's not going to work. So the value error is one type of error I'm expecting if I have missing data. So this is called, those errors are called exceptions. And what you're going to do is you're going to try this operation and catch the exception and deal with those exceptions separately. So remember I said, if I do a floating point on the fifth, on this sort of fifth row of actually fifth column in my data, that I'm going to say, well, if this throws an arrow, I'm just going to reassign the value to be none. So if you do that, it's going to be okay because any of those missing value you see, let's see if I can give you an example. In any of those missing value I see, I'm going to replace it by none. So those are the two rows where the last, right? Remember, it's a row 5, so it's 0, 1, 2, 3, 4, 5. So it's the last one. It's an empty record. Your missing value, I'm going to replace it by none. Okay. But of course, this is just a taste of it. You can also imagine if my fifth sort of column has missing value, some other column might also have missing values, right? So what you actually, if you want to be very safe, you are going to try to catch value exception for all of those so that in some sense you can actually add more lines here to say, oh, well, if there's value error for row 2, what I'm going to do, I'm going to assign row 2 to be none. And I'm going to assign rows 4 to be none and row 5 to be none. Okay. So that's something you need to pay attention when you are reading a file. Now, if we are going to use sort of Panda, we can do the panda dot read CSV and just provide the CSV file. Is going to be very simple, right? So everything I've done so far, I have not used pandas. I have just using the CSV library. Now I define the panda. I want to read a CSV file. Everything I have just done is now translated to a single line. Okay, beautiful. And we're going to move on to data frame, which is even more beautiful. Okay, so now if you got this, now did you see the nice representation of this? This is going to process the CSV file you just saw into columns and rows. And of course, I didn't provide the parameters here, so it's going to use the default parameter, right, which is comma and double quotation marks, right? And this is nice, okay? So now, why we want to use Panda for project down the road is that this read CSV function is what I would call insanely powerful. Okay, so all the pain you have to take, all the pain we have to suffer through just now is now translated into this. And of course, there's another sort of parameters you can do when you're reading CSV, when your CSV file does not have sort of the more standard formation. Yes.
What if the CSV file doesn't have the standard
Yeah.
comma and then double quotes?
Exactly. So let's look at it right here, right? So this is someone, I praise to him, painfully implemented this function with many, many, many options, okay? For example, if you have a separate symbol here in your CSV file, you're going to replace this particular parameter to specify, right? For example, sometimes it's a bar, right? People like to use a bar. You can use it with a bar to separate it, and so on and so forth. You can go through, I think there must be at least 25, or maybe actually 1, 2, 3, 4. Yeah, I would say 30, maybe. That's a good estimation of parameters. So if you have a non-standard CSV file, you can use some of those options to parse it, okay? Okay, let's get back. Now we're moving on to data frame. So data frame is what's called a column-oriented data structure, where each column is a Pandas series. So we remember a series, think about a series as a column, and the data frame is a collection of those columns, which is a table, right? So now, if I want to specify, let's first specify a data frame from scratch. So this is what I'm going to do. I'm going to say, well, I'm going to create a data frame. Think about data frame. The best way to think about a data frame, it's a table that contains my data. So when you think about a table, there's row and columns. So in this case, I am going to, so let me just print it out. I'm going to create a table. And the way to create the table is I'm going to have, the sort of the name column to be the singer's name. I'm going to have the no numbers column as a bunch of numerical values. And I'm going to have the new album column to be a bunch of, it's number of members and number of columns, right? To be a bunch of values. So by doing this, I just literally create what's called data frame, which in your sort of mental image is just a table of data. Of course, the best use of data frame is to read from a CSV file and create this table. Okay, so of course, this is an example where I initialize it. Remember, this is a curly bracket. This is a dictionary. So I'm initialize a table with a data frame with a dictionary. And of course, you can access it. Remember, I have the name column. I have the number of member, number of album column. If I specify the name column, it's just going to return that column with the values. Of course, it's going to always come with the index. You can also check what is the type. Remember, this is literally every single column of a data frame is a series. So if you check the type of that column, it says it's a series. Okay.
It's the same with the other one, right? With the, I mean, all the other ones we were using earlier. They're all series.
Yes.
They're all series. Each row is a separate series as well.
No, in data frame, every column is a series. Okay. So, but once you know it's a series, any operation you know how to perform over a series, you can perform over that column.
Oh, but before, so the data we were reading before, we just.
Oh, the before is a list.
That's a list.
Okay, so the difference, remember the series always usually come with like a key value pair. So there's always like an index kind of thing. A list, it has a default like numerical index underneath it, but it's not stored with that index. Okay, yes.
How are series different than dictionary?
You can initialize a series with a dictionary. Good question. I have to think about it a little bit. A series is a bit more powerful than a dictionary. That's how I would say. But underneath mechanism is actually similar because remember you can initialize a series with a dictionary. So they both actually uses this hash table kind of scenario. But you know, on the surface, I'll get back to you on this question. On the surface, a series is much more powerful than a dictionary. Okay. Now, you can remember I can create this data frame. I can access a column. I can also look at the type of the column. And because it's a series, anything you can do with a series, you can do it. Now, we can also create a data series from rows. So the previous example, I'm specifying it column by column. So this is the first column. This is the second column. This is the third column. Because it's a table, essentially, I can create this by row, but the syntax become a little bit complicated and it's not usually used, but I can give you example. So in this particular case, I'm creating the same table, except I'm providing row by row. So the first row is the name column has this value. The number of album column has this value. The number of members has this value, right? It's just specifying row by row and create another other data frame. Now, the interesting thing is that a series, remember, it's just a single column. So in terms of axis, you don't have a single axis, but a data frame is a table, so it has two axes, right? A column axis and a row axis. So when you actually do this, it's going to say, well, this is the first axis, which is really the row axis. It starts with 0, it stops at 4, not reaching 4, with a step size of 1. So it says 0, 1, 2, 3. That's this first row axis. And now I have a column axis. The column axis has sort of column names, name, number of album, number of members, and so on. Okay. So now I can access the axis. What does that mean? If I do the axis, it's just to say, well, tell me what is a row axis. Row axis is just a range going from 0 to 4, not touching 4, 0, 1, 2, 3. And what is my column axis is just has the column names. So you can access those axes. Now, there's tons of things you can do with exploring data frames. So pretty much anything you could imagine that you want to operate over a table of data is something that data frame would offer. Okay. Remember, I have hit album is now a data frame. So why do this data frame hit album.head without providing this parameter by default is going to tell you the first 5 rows of your data. So sometimes when you process data, you want to take a quick look whether you process it correctly. You look at the top 5 rows. Similarly, you can do if you provide a parameter, 8 is going to tell you top 8 rows, and you can kind of inspect your data in this table, in this data frame. Similarly, if you do tail, it means it's going to return the last 5 rows of your record. So this one is here. So why do you want to do head and tail sometimes? If you notice, when you do this table, when you do tail, you have now the missing value, right? You have NaN right now. So this gives you a sense that, well, okay, maybe not all my records are perfect. So of course, now you see this, you can kind of do some, you can do some operation, which is in a few lines. But right now, let's say, well, if I want to see the whole thing, so I can just say display max rows, none. So this particular line is just to see, I actually want to inspect all my table. Of course, in this case, I only have like 100 or something. So it's okay. So you can run this command and I go through like, 100 of my record, 66. So it's not too bad, but be very careful to not run this when you have a huge data file, right? If you have a file that is 10 million lines and you do this, and yeah, it's going to drain a lot of memory. And maybe it's when I even remember everything here when I'm doing this, I'm holding everything in memory, right? So sometimes for a really large data set, it will not fit in your memory. So you don't want to do this, but you can still do head and tail. Okay. Now the next thing, the shape. I do remember in Piazza, there's a question about shape. Shape also happens when you're dealing with vectors and matrices and so on and so forth. It's the same thing. Similarly with table, when you do shape, it's going to tell you number of rows, number of columns. So if I do dot shape, what is this? It says it has 77 rows, right? Remember, it's indexed from 0 to 76. So 77 rows, and it has 6 columns, okay? And same thing as before, where we can do dot info, that's going to tell you all the information you want to know about this data frame. And pretty much the information about this table, right? The column, the first column is about artist, second column is about album, third column is about release, and what is the data type. However, you have to be a little bit careful. Sometimes it's going to say, well, okay, this first column is an object, date released is an integer, and so on. It's going to try to make its best guess of what that type is. So sometimes it may not be accurate what the type is. This is actually a really important piece here. It tells you how much memory it takes to store this, okay? Of course, this is very small, and modern laptop have a pretty good memory. But if you have a larger data set, this is actually quite important to tell you how much memory this data set is taking. You can do describe. Now describe is the statistics associated. And then the beauty of it is this is now statistics associated with the numerical columns, right? So for example, of course, this is taking the year and treating it as a number and do the statistics. This is taking the sales millions number and do statistics on it. You can also just focus on specific column statistics. So if you provide a column, yes, go ahead.
So what happens if, I guess your data is not set up in columns, but like in rows, you transpose it first?
You could, well, you can also do some row operation. You can actually see some row operations very soon. If you can, if it's much more natural to operate over a column, then you should like do some transformation. But there are operations we're actually going to see in one operation where if I'm feeling missing number, I can feel missing number from the previous row. I can also feel missing number from previous column. So there are operations you can still do, right? Ultimately, it's a table and you can operate per row and per column. Yeah.
And like for to describe, I guess, is there something that you can see so that it's on the row rather than
I have not tried it actually.
Wait, I don't understand the question.
Okay, so if you see right now, I'm doing by default when I do describe, I'm doing statistics per column, right? Because this column is just the year, so I can do statistics on it. His question is, can we do statistic over the row? We can try it, but let's first go through my content and then we'll come back and then do some experiments and see what we can do. All right, so now if I can do describe by just taking a single column. For example, here, this is to say, well, I only care about the statistics associated with the column that is called artist. So this is sort of, and it's talk about how many record do I have and how many unique record do I have and what is sort of the top artist in this column and how frequent does it show up, right? So again, previously, if you don't rely on data frame, you have to write your own function to try to capture those statistics, and this comes with it. You can also count values. So this is to say, well, among those 76 record, I'm counting artists. I'm going to say, well, how many record does Michael Jackson have on the top hit list? It says it has 5 albums. Madonna has 3, and so on, right? And then it's going to show all the statistics of the artist, okay? Now, there is, of course, statistics you can do, and Anna will talk about more. You can also study correlations, okay? You can talk about correlation method, and then this is by default looking at sort of Pearson correlation. And you can also do, this is going back to your question, dot T is your transpose, okay? But sometimes when you're coding, of course, you are the developer, you know exactly what you're doing, but you have to be careful that to well document your code, because if somebody later on is try to read your code and not pay attention that you did a transpose, that some of the code would not be understandable for the next person who's reading your data or reading your code, okay? But yeah, if you're more natural, so now going back to your early question, if I transpose it, then I can do my statistic per row as before, okay? Okay, so I can do slicing as before. It's a table. I can slice anywhere I want. So now what does this do? This is slicing over this particular column and it show me the top 5 row. So this is just the first column, give me the top 5 row. Now I can specify also the specific column I care about. So this is a large table. I only care about the 3 column, which is the artist name, the certified sale, and then the claim sale, and give me the top 5. Okay. So now it says, you know, Michael Jackson has the top most certified, and usually the claim sale is higher than the certified sale. Okay, now we are going to talk about iLog again. Remember, I start today's lecture about iLog and log, how it's operated with series. because each column is a series, you can do the same thing. So now, however, you have to be a little bit careful is when you are doing ilog operation, and this is sort of a little bit exception from Panda data frame, is you can actually do things like this. So what did this do if I run it? This is giving me the first 3 rows starting from 0 index, so 0, 1, 2. And remember before, I need to specify things in here where I highlighted to be column names. But the reason, one of the argument I believe that they implemented this is that it's very common for people who want to see like row IDs. So that's why this is a little bit break away from the convention. Okay, so remember for data frame, when you do this, you're actually looking at rows. Okay, now, if I want to look at columns, I can still do this. I can provide a list of column, a sort of name, and I look at the top 3. Yes, is there a question? No, okay. Okay, yes. So this one now is to say, again, I'm looking at my table. I'm looking at the 3 row, certified sale, claim sale, artist. Notice the difference between this and the previous one. I reordered it, right? Previous one, the first column is artist, and then the claim sale and claim sale is second, this is later. But if I reorder it, this is again, just say, I'm going to slice my table and I'm going to rearrange it, okay? So again, dot head, top 5. So one way to think about this is like the hit album is basically a table. It's a data frame that you can access it in many different ways. So this is now advanced multiplication. Remember the default index are 0, 1, 2, 3, 4. I can also reset my index. So if I reset my index and I reprint my table, is that now I'm forcing my artist column to be the index, right? So one way to think about this is that, okay, by default, every student has a student ID and the student ID is your index. But, you know, assuming everybody live in a different address, then I can force the address to be your index, okay? And again, you can do the top 5. Now let's move on to the lock operator. This syntax should not be too surprising for you. It's basically say, tell me the data in particular row and a particular column, right? Because it's a table, so I can access it anyway. So now here, if I only specify heat atom meatloaf, this is going to just return the row that has meatloaf as artist and what is the sale and claim sale, okay? If I do Michael Jackson, it's going to return all the record that, remember this is re-index, so Michael Jackson is now my index. So it's going to say return all my record who is associated with Michael Jackson, right? So remember this is an index, so it's going to say there's 5 record of it. Now the next thing is I can of course only use it to also access columns. So this is saying that I'm going to look at the record that is solely associated with Michael Jackson, but only the column associated with the certified sale. If I do this, this is just to say, okay, this is a record associated with Michael Jackson. This is a corresponding column associated with certified sales. So again, all those are just small variations of how you're slicing a table. So let's make it slightly more complicated. In here, what is going to access is I'm going to access all the record associated with the index Michael Jackson, which is key. Index sometimes is also like key and meatloaf. So anything that associated with Michael Jackson or meatloaf show up, and I'm going to look at the column that is certified sale. Okay. So another way to think about the syntax of lock is it provide a range of the row index and a range of the column index, and then you can access a subset of your table. So if I do this, this is to say, I am going to locate, assuming that there is a range of band between Green Day and Supertramp. If I do that, it's going to say, okay, I'm going to look at all the record in the current ordering of the index between Green Day and Supertramp, right? But if I run the second part here, this will not work because Michael Jackson show up multiple times as an index, right? The previous one worked because those are unique ones. So the Python knows exactly where to start, where to end. But Michael Jackson has multiple records, so it will not happen. So this is, yeah, go ahead.
So could you say, show me all the indexes between first Michael Jackson and last Michael Jackson's occur?
That require a little bit advanced coding, right? Yeah, it's not going to look pretty if I put it into one single thing, but you can do that. What you can do is you first locate all the record that is Michael Jackson, figure out what that index is, and then provide those index.
Oh, okay.
Right? Okay. So what I have done before, I can make it more condensed. So this is again, anything between Green Day, Supertramp, and then the column. So I'm going to reload for the time being, just read CSV. And now I'm going to create a slice containing all rows and column between artist and release. So what does that mean? This means I'm going to go from this column to this column. So those 3 columns. So again, look at the index. This is saying that I'm going to take all rows. And then for each of the row, I'm going to take all those 3 continuous columns. And again, I'm just slicing my table. Okay, let's keep going. Now, I can also say, well, I don't want all the rows. I only want my row up to index 10. Okay, so this one, again, is breaking from convention. It's up to, but include index 10. So this is something just to remember. If I do the lock from nothing to 10, this means I'm going to take everything up to index 10, so include index 10. But if I use iLock, which is another slicing techniques, it's going to go from 0 to 11, but not including 11. So those 2 are going to provide you same result, except that this one here goes to 10 for lock. This one goes to 11 for iLock. Okay. Another thing for iLock is actually just providing the actual index-based accessing. So in order to access the columns that I care about, I need to provide the column index starting from 0. Actually, it's actually 0, 1, 2. Those are the first 3 columns that you care about. Remember, we talk about broadcasting. We can do the same thing as broadcasting because they are just operating on series. So in this particular case, I'm just saying that, okay, I'm going to take my my series, and I'm actually taking my data frame, taking the column that is certified sale, and convert it to a number. This is by millions, but I'm going to multiply by 1,000,000 and return to, and kind of replace it. So what does it do? If you look at the certified sale column, before it's just by millions. After, I create a new column called certified sales, and that is in real dollar. So this is a new column that I just did. So actually, we have to be a little bit careful. This is a new column because if you actually look at the column name, this is a new column I have appended to the current table. Right? Same thing as before, you can do masking. Okay, I can create, to do that, first of all, let me just create what's called a Boolean series. This is just taking this particular column and to say all the album that is released after 1990. If I do that, this is just a Boolean thing, right? Whether this is false or true, whether the album is created afterwards. This is similar to the filtering we have done before, filtering and masking for the series, because each column is a series, so I can do this. Now I can apply this mask to my data frame. What does this do? This is now only keeping the album, the rows, that is album released after 1990. So as we move on, as you can see, I'm already start doing a bunch of data wrangling, right? Again, my data wrangling of my table is based on the masking and filtering with the series. You can simplify this line exactly as before for more condensed code, right? You say, this is my mask. I provide the mask to my log, which basically says that, or the record that satisfies this is get filtered or kept, and I'm going to do the same thing. So this is more condensed coding. Now we're coming back to handle NaN values. Remember, we say we can do, let's just look at the tail. One thing that is very interesting for the tail record is that, well, I have those NaN. So the first thing I'm going to do is maybe I can just drop all the record with this value. So if I drop it, now remember I have 76 record, but if I do drop NA to drop all the NaN values, you're only going to get 30. So this is not sometimes a so sometimes you might want to do this, but sometimes it's not a good practice because you lost more than 50% of your data. So then what do we do? Well, maybe I can replace, this is where fill NA become powerful. You can replace NA value by some other value. So for example, if we say clade cells, if there's NaN value, I'm going to replace it by 0, right? If it's a missing value, I'm going to replace it by 0. This is done by fill NA, okay? So when you do fill NA 0, that means all NaN is going to be 0. So if you look at the tail of it, all those is replaced by 0. Now, this is the more powerful thing you can do. FF fill. FF fill means forward fill. It's just going to say, if there's an NaN value, I'm going to use the value from the previous row and copy it. Okay, so let's see what it does. If I do that, that means, well, this row has a value of 30. Then the next row, because it's NaN, I'm going to replace NaN with 30. What is the argument? The argument is that, well, those are sorted. So maybe I can replace a record that don't have a claim sale by the last record that has a sale. So this is fairly reasonable. But the other thing you can do is, instead of having the value from the previous row, you can have the value from the previous column. So for example, if there's 20 here, and then I have NaN, maybe my claim sale is not going to be smaller than the certified sale. So I'm going to copy this value over. And this is operation that is copying value from the first column to the second column. And in order to do that, I'm going to do forward fill, except I'm going to specify the axis to be 1. The default axis 0 is a row axis. And when you switch to column axis, which is axis 1, you are going to do it from the previous. So now if you actually look at the end of this, what happened is that every single record who don't have a value here is going to take the value from previous column. That is a forward fill. And in this case, I might argue this is a good option because you know that the actual claim sale is not going to be smaller than the certified sale. So that is a reasonable sort of way to deal with missing. And finally, I don't know how much time I have left, but I'm going to talk about a little bit more, which is grouping. And if we don't finish, I think Anna will pick over. I'll let her know. You can group by artist. What does this do? Remember, Michael Jackson has 5 records. I can group them into one single row. So when I do this, well, of course, it's going to look a little bit ugly. So let's actually just show the, okay, it's grouped together, but let's just look at the statistics. What the statistics does is that it is, so for example, if ABBA have multiple albums, once it's grouped, it's going to sum over all the sales of all the albums. So this is, think about this as a way to accumulate. And if you want to interpret this value, let's say Led Zeppelin. Led Zeppelin has only 1 row of record, but then Michael Jackson, where's Michael Jackson? Can anyone see Michael Jackson right here? Michael Jackson, when do the grouping, it says it has 5 different rows. Okay, that's what grouping does. Once you group it, you can do statistics like sums, like sort, and count, and so on. So I'm going to tell Anna to kind of repeat this last bit because I don't want to go further. But really, what it does is once you do a grouping operation, you can kind of aggregate your record. And once you aggregate record, you can do statistic and simple information associated with those. All right. Okay, so that's it for today. There is an exercise. Again, I would encourage you to try to do it with your classmate or do it on your own. And do it, not far from today so that it's still fresh in your mind. And a final reminder, homework 2 is due tomorrow. There is going to be office hour tomorrow morning, so make use of that. Okay, thank you guys.